Now let's talk firewalls. Firewalls are security devices, basically a security-focused network hardware device or software device. So a firewall on a network diagram looks a lot like this. It's going to look like a wall. You might have a little cartoon fire behind it. If you're interested in figuring out who the guy is who pops up all over the video, all over the slides here, you can watch the video linked here. So this is what a hardware firewall looks like. It's nothing super special to look at. It's got a port and some other ports. And so the console port you would use to connect and configure the device. And then it's got other ports to connect to various network devices that it is protecting. So you might have a hardware firewall like the one that I just showed you, or you might have a software firewall like the software on your computer. Windows firewall, Macs have a firewall built in. And those software-based firewalls are basically performing some of the same functions. They're blocking ports and preventing people from accessing, or preventing applications from accessing your computer through the network. And you might have network-based firewalls, which are, well, a hardware firewall would be a network-based firewall. And you might also have a host-based firewall, which is a firewall running on your computer. So a hardware firewall, physical, dedicated piece of equipment just for that. A software firewall is software running on your computer. Very often, host-based firewalls are software-based, network firewalls are hardware. And so that host-based firewall is basically software that's protecting a single computer, and you're going to have to configure that differently for each computer that has that host-based firewall, whereas the network firewall protects every device on the network with that same set of rules. And the way that it does that is through what's called an access control list. The access control list, or ACL, is really just a really long if-else or switch statement, if you're a programmer, that is a list of rules that define what kind of traffic is allowed into your network or out of your network. And if it matches one of these rules, you decide what to do with it. Either it gets accepted in or it gets thrown out. So what kinds of information can the access control list use to filter on a network? Well, there's a lot of things. Basically, if you look at Wireshark, if you look at network capture, you've got all of that information. A firewall can look at any of that information. TCP ports, source and destination, TCP, or is it TCP or UDP? Is it HTTP traffic? What type of protocol is it using? Is it secured or unsecured? Is it encrypted? Is it DNS? You can block by application. You can block by transport layer protocol information. You can block by IP address, source and destination. And we'll talk about some rules that you might use to block by source and destination IP address. And you can block by MAC address if you want to. It's less useful, but you can do it. You can block traffic by the data link layer, at the data link layer. So here is a software network firewall called PFsense. And PFsense is essentially an operating system. It's a firewall operating system for a computer. So you could set up a computer and run this firewall operating system on your computer. And the default rule in a firewall is throw everything away. And unless you specifically allow things to come into your network, it's going to throw everything away. So in this case, we've set up this firewall with 3 rules on the WAN, or external interface. So this is filtering traffic that's coming from outside the network to inside the network. So it's network traffic that's trying to get from the outside in. And I've set up some rules here that specifically, the first rule there is a delete, a drop traffic rule. And that rule is designed to drop anywhere, any traffic that has a source IP address that is reserved or not assigned by the IANA. So these are essentially traffic that shouldn't exist on the internet because these are not assigned or reserved IP addresses. People are trying to send this stuff into my network. That address shouldn't exist, so I'm not going to let it in. So this is a very good rule to explicitly deny that traffic, even though the default rule is to deny, because our next rules are going to allow some stuff in. And so this explicitly says, if this shouldn't exist, then delete it, get rid of it, and don't even look at the next rules that we have, because these rules are applied in order. And so I'm going to look at the next rule. If it passes that and it has a good IP address, then I'm going to look at the next rule and say, is it TCP traffic, destination 192.168.1.11, port 80, then I'm going to let that through. And that's a pass. That's that green little plus or play sign on the side. That says let it through. And the next rule is TCP for 192.168.2.12 on port 80, and I'm going to let that through. And if the traffic doesn't pass either of those two rules, then it gets thrown out. So by default, you're going to get rid of everything, unless you specifically allow certain things through. And that makes sense, because you don't, by default, want to allow people to enter your network. You only want people entering your network who you have specifically set up something for them to do, either an SSH server for them to connect to or something like that, because otherwise they're just going to get into your network and try stuff and see what they can do. So you're not going to configure a rule that says let everything through, unless you want to set up something like a honeypot where you're trying to catch attackers, and then you might let everything through to try and observe attackers and see what they do. So here's an interface for setting up a rules, and you can select block. Again, you can select protocol. Here I've selected ICMP, and you can select specific types of ICMP requests. So in this case, an echo request, and I can block ICMP echo requests. And that means no matter what else you're trying to do, if you send in an ICMP echo request, I'm going to block that and not allow that into my network. And again, I can check source IP address, destination IP address, ports, all of that information. And here's that new rule added to the list of rules. And he's blocking that. So on the other side, we've got a very similar issue from the outside, or from the inside going out. We need to set up and configure our firewall to allow traffic out of our network. And that's a little bit different than traffic coming into our network, because typically if you're setting up something that connects to the internet, then you want anybody inside your network to be able to connect to the internet. And so while the default rule is to delete all traffic, and it's still to delete all traffic, very often you're going to configure a rule like the second one on the list here, default allow LAN to any, which basically says anything coming from the inside is good. And unless you specifically want to filter, you might filter SSH traffic. You don't want people inside your network SSH connecting to anything outside your network. Or you might block SMTP if you don't want people inside your network connecting to SMTP servers outside your network. You might block those. But very often you're just going to basically allow anything from the inside to get out. And that first rule on the list, the anti-lockout rule, is important. And that rule is one that they won't let you delete, because that prevents you from completely restricting your access to the firewall itself. So this allows a destination inside of the network to get to port 443 and port 80, which are like the administration interface for the firewall is on port 80, or in this case, it's HTTPS, so it's on port 443. And without that rule, you might not have access to administer your firewall. And then if you delete that rule, and then you can't get access to the firewall to even add the rule if you wanted to. And that's a problem. So you got to watch out for that. Don't accidentally disable your access to a firewall. That's bad news. So what kinds of rules would you want by default in your access control list? Well, for one, you might want to deny local addresses. You don't want people from outside your network trying to look like they're coming from inside your network, because that's how a lot of denial of service attacks and things are run. So you're going to not deny those local addresses, meaning traffic coming from outside to inside that has a source IP address that's an internal address for me gets blocked, because that's somebody trying to impersonate someone inside my network. That's bad news. You would want to deny localhost addresses, because that's another type of attack. So there's no reason the source IP address for anything should be 127.0.0.1. That's bad. Get rid of that. Deny private addresses. Again, private addresses shouldn't be on the network, so they might be trying to impersonate somebody inside your network or just guess at a private address inside your network. In the case of the firewall that we looked at, that actually had private addresses because that was a private network that I had set up, and I had a firewall protecting one side of my private network from the other side of my private network. And then you might want to deny multicast addresses, and that's, unless you explicitly need multicast, that's an entire range of addresses that someone might try to use to attack you that you don't need. And he's going to block those. So you can also use a firewall to do NAT or PAT, and the firewall can be configured to do that. In this case, we have the top rule, forwards port 80 to 192.168.1.11 on port 80, and the other one forwards port 8080 to 192.168.2.12 on port 80. And those are two different networks. So if you send traffic coming in from the outside, traffic coming for port 80 goes to 1.11, traffic coming in on port 8080 goes to 2.12. Both of those are listening on port 80. So you don't have to change the way Apache is configured. You're just changing the way the firewall is configured. And Apache thinks, hey, everybody's talking to me on port 80. I'm good to go. So the last important topic related to firewalls is what's called the DMZ, or the demilitarized zone. And this is basically an area, a separate network segment where you put common security targets. And specifically common security targets that you need to access from outside your network. So, for example, web servers, mail servers, DNS servers, if you have people inside and outside your network that need access to those things, then you need to open those up to the internet. But by opening up to the internet, you're basically opening them up to the threat of someone attacking them and trying to get in and potentially compromising those. And so you don't want to open up everything and open up your entire intranet, internal network to those kinds of attacks. So in case somebody compromises your SMTP server, they don't have access to your entire internal network. So you set up with your firewall what is called a demilitarized zone. And this is a separate network segment that has fewer restrictions, and it's has a different level of trust. Basically, you don't trust traffic from the demilitarized zone the way that you trust traffic from the intranet. And you might treat it more like external traffic than internal traffic as it's coming into your internal network. And you've got a couple different ways to configure that. You might have one firewall where one of the ports on your firewall is connected to the demilitarized zone, and you would configure that in the firewall settings and tell it that this port is connected to the DMZ. Or you can have actually two separate firewalls where you have your internal firewall that's completely locking everything down, and then separately your external firewall that's a little bit more relaxed to allow traffic into the demilitarized zone and into those targets.